Hello, everyone. My name is Brigitte Skakabek. I'm a product marketing manager at VMware in the end user computing group focused on Horizon. And with me today is Alex Berger, my counterpart in VMware's networking and security group. And today we're going to talk to you about deploying enterprise secure desktops and applications with VMware Horizon and NSX. Security challenges we face are summed up quite nicely in this quote from IBM's president and CEO, Ginny Rometty. She said, "We believe that data is the phenomenon of our time. It is the world's new natural resource. It is the new basis of competitive advantage, and it is transforming every profession and industry. If all of this is true, even inevitable, then cybercrime, by definition, is the greatest threat to every profession, every industry, and every company in the world." I think we know that security is a major concern for most organizations. In recent years, there have been a lot of reports in the news, and it talks about sensitive corporate and personal data being compromised. And these breaches occur despite the fact that we're more focused than ever on security in the enterprise. And we have more stringent data protection laws like GDPR. We're making big investments in security technology, and our security teams are becoming more and more capable. In their annual data breach year-end review, the Identity Theft Resource Center confirmed that 1,579 data breaches in 2017, and this was 44% higher than the 1,091 disclosed in 2016. And business organizations, namely retail, hospitality, trade, and utility, accounted for 55% of those breaches. And that was followed by medical and healthcare industry with 23.7. So definitely there are certain verticals being targeted, but nobody's immune from these data breaches. The Ponemon Institute has documented that the average cost per security breach in 2017 was $3.62 million US. And actually, this is slightly down from the previous year. But desktop and application virtualization with VMware Horizon can go a long way towards increasing your overall security posture. And when you couple that with VMware NSX, you get a truly robust end user computing environment can be realized. So there are many factors leading to this problem that we're facing in security today. So the nature of attackers and the attacks themselves have changed over time. So attackers are becoming much more sophisticated, and we're seeing an increase in organized crime leveraging cyber attacks. And insiders are increasingly becoming the perpetrators of attacks. And there's also cyber terrorists, hacktivist groups, and even nation states that are executing more and more advanced and persistent threats. You've probably heard of major breaches in the news from the likes of Marriott, Equifax, eBay, Yahoo, Sony, and many, many more. So if we drill down and pick on eBay for a moment, they had a breach in 2014. It compromised 145 million users. And attackers got inside the company network, and they had complete inside access undetected for 229 days. And in that time, they managed to make their way to the user database. And this is not uncommon. So data from the Ponemon Institute shows that the average time it takes for an organization to detect a breach is 191 days, which is slightly down from last year, but there's obviously still quite a ways to go. And this weaponization of cyberspace with toolkits like Zeus and Black POS means less sophisticated attackers are really able to, partake in cybercrime and have these sophisticated attacks more easily than ever before. So how can Horizon help strengthen your security posture with all these looming threats? So with the advent of desktop and application virtualization, we've really solved a number of problems in the enterprise. So first and foremost, inherent sort of in virtualization itself is eliminating the loss of data that are sitting on these edge devices, so these endpoints. Think about that laptop. It has customer, patient, or financial information, and it's sitting in the back seat of a rental car. You don't have to worry if the data is in the data center. And we've addressed unauthorized access with data desktop provisioning based on identity or role, and by the ability to deliver applications on demand as well. And we've reduced branch office infrastructure, so we can sometimes eliminate the file and print or application servers in branch offices, because now the desktops and application have been moved into a centralized data center. And backups are going to be easier when things are centralized as well. And finally, when you adopt a modern desktop application virtualization technology, you can centralize the image management. And this makes it easier to kind of deliver these software updates and the patching and keeping your environment up to date. And even antivirus is going to get easier. And from a technology perspective, we've really addressed a lot of the security concerns just by taking desktop and application virtualization and putting it into the modern enterprise. So in addition to the inherent security benefits of virtualizing desktops and application that we just discussed in the last slide, so with VMware Horizon, you're going to get trusted images every single time. So with our instant clones technology, every time a user logs in, they're going to get a brand new, fresh desktop. And every time they log off, their desktop is going to be completely destroyed. So you can imagine that any malware that may have seeped in during the session is also going to get destroyed along with that desktop. And how this works is that instant clones, the clone that the end user, the clone desktop that the end user is powering up, basically what we do is we allow this desktop to power up to a certain point, and then we stop it, we stun it. And we wait for an end user to come along and ask for a desktop, and then that end user is going to restart that powering on process. And I should mention that we stop it right before we grab resources. So before we grab any compute or memory resources, we stop it. And then again, when that user comes along to power up the desktop, it's much further along in the power up process. So it's going to take a lot less time for them to get a powered on desktop. And because the login time becomes so compressed and so short, we can destroy the desktop at log off and get that brand new desktop again at login. So it's really a security enhancement to be able to use the instant clones. And also management is centralized, as I mentioned before, and it's going to make it easier to keep those images up to date with the latest security patches. So if the image needs to be updated, patched, what happens is you update the parent image, and you can swap the parent. Once you have that updated parent image, you can swap it out. And the next time that user logs in, they're going to get the latest image. So there are zero downtime updates. And with app volumes, apps can be provisioned real time. So you can do on-demand apps. And you can also sort of do identity-based provisioning. So you're not going to get every single app that you don't need, just the ones you need with app volumes. So to recap, instant clones and app volumes, they're two pillars of our JUMP technology, which is our just-in-time management platform. And this JUMP technology is the basis to give admins the ability to deliver non-persistent desktop. And in a nutshell, non-persistent desktops are desktops that are that get destroyed basically at log off, and you get that brand new one at login. And this is really going to enhance the security posture. So the other pillar of our JUMP technology, the third pillar, is User Environment Manager. So with User Environment Manager, Horizon also offers user personalization as well as smart policies. So when you're offering every time you log in, you get this brand new desktop, you kind of want your wallpaper, you want your font size, you want sort of everything that's personal to you. You don't want a vanilla desktop. So as we create this fresh, brand new desktop, we kind of have to snap in all this personalization so the user feels like it's the same desktop they've been logging into every day. They want their files, they want their network mappings to their local printing, and Horizon delivers that personalization based on a bunch of variables, such as your identity and your role, or your Active Directory group, or perhaps your location, your operating system, or even device types can provide context. So not only can Horizon personalize based on these parameters, but IT can create policy as well. Because with the virtual desktops, the policies are tied to the end user and not to the underlying hardware. So this means that IT can provide end users with a truly contextual user experience. And the policy can dynamically change depending on the device being used or location the services are being accessed from. So end users can securely address corporate data and applications across sessions through one set of login credentials. So if you take an example, sensitive data might not be able, you might not allow end users to copy it onto a clipboard on a personal device. Or maybe there's, device or location-based restrictions with printing or copying. So there's really, UEM, as we call it, User Environment Manager, provides very powerful controls. It has a single user-friendly console that works in harmony with Microsoft Group policy. And doesn't require any dedicated hardware or databases. And when you have a virtualized environment, there's no real need to have sort of a PC as an endpoint or laptop as an endpoint. You have the option of having a thin client, which is kind of a bare bones endpoint, since you're accessing your desktop in the data center. So thin clients are really a cost-effective endpoint option to support virtual desktops and applications, and they really offer several advantages. First of all, data is not going to be stored locally on the endpoint. So if you lose the endpoint, it's not the end of the world. The power consumption is quite a bit lower with thin clients, and they're designed with a 7-year life cycle. So if you compare that, you can imagine how much cost savings you're going to get. If you think of a laptop, I think the average life cycle of a laptop is on the order of 3 years. So you're going to get a much longer lifetime with the thin client. So of course, Dell's one of our partners, and the Dell Wise Zero clients and thin OS-based thin clients are malware resistant. So their API is completely unpublished, and there's zero attack surface. So to date, as far as I know, the Wise Thin OS has never had a virus. But if you have a thin client that's running on Windows, it is more vulnerable to cyber attacks. But advanced threat protection like Dell Threat Defense can prevent 99% of executable malware. And this is going to be much, much better than just using antivirus solutions alone. So I've walked you through how desktop and application virtualization can improve your overall security posture, but there's really an important point that also needs to be considered. So what measures, need to be taken to ensure the network connecting the virtual desktop infrastructure is secure? And now I'm going to pass the ball to Alex, who will take us through network security considerations for VDI environments and how VMware NSX can help.
Thanks, Brigitte. Appreciate it. Yeah, so, when it comes to securing these environments, it really does come down to reducing the attack surface as much as humanly possible. And of course, for VDI itself, Horizon itself does a lot to help reduce the attack surface within the endpoint itself, right? Things like enabling single sign-on and the different authentication measures that it can do. Even just the notion of instant clones and persistent desktops is awesome for reducing the attack surface of your overall end user environment. But the fact of the matter is that no one solution is a panacea, right? And ultimately, if you look at the anatomy of most attacks, they make use of things that aren't necessarily technological in nature, right? So for instance, I want to dissect an attack here on screen of actually a real attack that took place with one of our healthcare customers, and we'll walk through how this actually happened. And in the end of the day, you know, they do make extensive use of VDI, but it, you know, through no fault of VDI itself, you know, a user just ended up messing up, right? So this healthcare organization, as I said, makes extensive use of VDI. In particular, what they do is they use Horizon to give clinicians a desktop that will follow them throughout the hospital. So as the clinician moves from room to room, their desktop moves from room to room with them. And all they have to do is badge in using an ID badge to each computer. They don't even have to type a password, and their desktop pops up no matter what room they're in, which is really fantastic for maximizing the efficiency of clinicians. And of course, badge tab technology helps them make sure that those, you know, the physical terminals that they use are secure as well. But what happened in this case was an end user had access to a VDI system that they used to access patient information, things like that. And on Friday at 8 p.m., this user ended up clicking on a website that she didn't realize was infected, right? And it actually prompted malware to download to her VDI instance and, you know, her desktop. And she actually, what's funny about this situation is she knew immediately that something was wrong. So she actually reported to IT on Friday night that there was an issue, and she thought something had gone on. But because this desktop was part of the VDI environment that sits behind a perimeter firewall inside the data center and does have access to the internet, unfortunately, it was just user error, right? There was nothing that could have been done to prevent this from an end user security perspective. And because this environment was contained within the data center, these systems, these desktops actually had access to lots of critical systems throughout the entire data center. So we got this propagation, right, where the malware basically spent all night moving unrestricted throughout the entire data center, looking for information to steal. And eventually it found some, right? So within less than 12 hours, right, we started Friday night at 11 p.m., the attacker had found sensitive information and started exfiltrating it, right? And before IT could get in Saturday morning and actually do something about this, 12 hours had passed. So it took 12 hours, 9 a.m., security response begins. And of course, there's a little bit of a lag between, you know, when response begins and when the threat can actually get mitigated. So even despite being everything going right from an end user perspective, other than clicking on the link, of course, reporting things to IT that they knew were to be amiss, etc., there still wasn't a response that was quick enough to prevent a significant loss. And that, of course, is the case normally, right? If you look at most of the attacks, the vast majority of the attacks in the last, I would say, 8 to 10 years even, they follow this pattern where it's not even a technological problem at first, right? Some low priority system is targeted by the attacker. It's a phishing email or a spear phishing email. Some sort of social engineering is employed to get an unsuspecting user to click on the wrong thing. And at that point, the attacker has carte blanche access within the data center because there are very few internal network security controls in place to prevent this east-west movement of threats, right? North-south is from the data center out to the internet. East-west is across the data center itself. So we see this time and time again. And the question, of course, is how do we mitigate it? What do we do about it? Well, in an ideal world, what we would do is we would employ firewalls on every individual desktop and server that exists within our network perimeter, right? Every individual desktop or server would have essentially a little wall around it. And they'd have individual security policies tailored to exactly what they need. Now, the problem with doing this in the past, the reason we haven't ever done this before, is because trying to do this with physical and even virtual appliances is really difficult. It's really consumes a lot of resources. It's extremely difficult to manage, and it would require a huge cost to actually deploy those appliances everywhere on the network. So we'll get into how VMware actually enables this in just a minute. But let's talk a little bit more about our ideal scenario, right? So we have a wall around every individual VM, and with that wall would come custom policies that are specific to that VM. Now, what VMware actually is going to allow you to do is not only define these little perimeters around every VM, but base their policies on just about anything. And we do this because we're embedded in the hypervisor. We'll talk a little bit more about how the architecture in just a second. But this allows us to go well beyond the general IP port protocol based policy layer that you get with most firewalls. We can design firewall policy based on pretty much anything related to the VM. Could be VM names, could be the operating system running on the VMs or desktops, could be application attributes. So for instance, if we know that a given set of workloads needs to be governed by PCI, we can design a PCI scope and insert policy to those individual workloads, but define it at the scope level, right? And this is really great, right? Because this allows us a lot of flexibility about how we design security policy to prevent that lateral movement of attacks throughout the data center. Now, the other beautiful thing about the way NSX and VMware allows you to do this is it's entirely defined in software. There's no need to use any other you don't need to purchase or deploy any hardware. And really, but beyond that, that's obvious, right? If it's software defined. But the other beautiful thing is that this allows us to be incredibly agile. We can change security policy without having to log into a bunch of different physical appliances and aggregate and manage across many different appliances in the entire environment. We can do this in this distributed fashion that allows us to really change policies as much as we want. It also allows us to get automated. So Brigitte was talking about how one of the huge values of doing VDI with Horizon is that we have these instant clones, right? And you can get this non-persistent desktop architecture in your environment that allows you to delete desktops when they're no longer being used. Now, the problem with that from a networking and security perspective is somebody, when those workloads are spun up, could be on a daily basis, right? Those desktops get spun up, and now security policies, traditionally, we don't have time to log into a firewall and figure out, well, how am I going to firewall that new desktop, every time it's born? Well, with a software-based solution, we do have the ability. We can automate. So as soon as a desktop becomes live, we can automatically apply the security policies that we want from a network perspective. And we can do this for groups of desktops as well. We'll get into a little bit more about what that looks like in just a second. The other beautiful thing here is that we also aggregate and centralize all the control and management of all these firewalls. So this is a little taste of what we can do from a firewall perspective. This is the ideal situation. It really kind of hinges on this notion of zero trust. Don't let anything communicate with anything else in your entire environment unless it has express permission to do so. And really what NSX is doing is helping you to operationalize zero trust within your network boundaries. Now, of course, I'm sure you're all wondering, well, how? How do you do this? And I'm going to just very briefly go over the NSX architecture so you can get a sense as to how we actually deliver this solution. First of all, it starts with your existing network, storage, and compute infrastructure. From a hardware perspective, as I said a minute ago, you don't have to change anything. NSX is really an overlay technology, very similar to ESXi is for the compute world. And of course, NSX, as I also mentioned a minute ago, does leverage ESXi when it's there. It can also supports other hypervisors as well, and even can be deployed on container frameworks and bare metal servers, etc. But really, what the concept remains the same. What we're effectively doing is taking these core network and security services, things like routing and switching and load balancing, and of course, firewalling, and we're embedding them directly into the virtualization layer. And the right half of this diagram here represents the cloud. We also run all these things as a service in the cloud as well. But what this allows you to do by embedding everything into the virtualization layer is it allows you to actually build a virtualized network platform, right? Essentially an entire construct that is the virtualized networking and security layer. And on top of this, you can connect and protect virtual desktops, VMs, containers, bare metal servers, whatever you want, right? And what's, I mentioned this a minute ago, but it's worth bringing up again. This distributed notion of firewalling is really at the core of the power that NSX provides from both a desktop protection perspective and a server protection perspective, because we're embedding firewalling directly into the hypervisor. And to illustrate this a little bit further, let's look at how this would work. How would you firewall between two workloads without NSX Data Center versus with NSX Data Center? On the left, we have without, of course, and you can see in this diagram, very simple network topology diagram, but we have two workloads sitting on a single host connected to the network. And let's say I wanted to firewall traffic between these two workloads living on the same host. Well, to do that without NSX, what I'd have to do is I'd have to send that network traffic through the physical host, out through a switch, through the routers, all the way out to my edge firewall, my perimeter firewall. And then I'd have to route that traffic all the way back in the exact same path through the exact same router, switch, and physical server to the VM sitting next to its fellow there. Now, that's pretty complicated, right? And it's also means that you're taking a performance hit, because all that hairpinning of traffic, it's unnecessary. You're sending a lot of unnecessary traffic across the wire. When you deploy NSX Data Center and you embed firewalling capabilities into every individual hypervisor that's in your environment, now, in order to firewall between two VMs, all we have to do is send that traffic through the hypervisor, through the distributed firewalls on that hypervisor, into the other VM. So we've completely eliminated that hairpinning of traffic. In fact, the traffic never even leaves the physical host without sacrificing security. And that's really at the core of, what drives microsegmentation, which is what we call, that granular deployment of policy on the individual VM level. That's what is at the, at the core of how this works and why it's so powerful. Now, what I want to do is take a minute to apply these concepts directly to the Horizon use cases, right? How VDI environments work. And I've got a series of use cases here to talk about. Let's start with protecting desktops. So if you recall from the anatomy of the attack slide that I showed a minute ago, when you have this attack coming through and infecting a specific desktop, that attack is going to look to spread, and it's going to spread to anything that desktop has access to. In most VDI environments, there is pretty much unfettered access across all of the desktops in the environment themselves. And really, that's completely unnecessary. There's almost never a time where you actually want your desktops to be able to communicate with each other for practical business reasons. Well, with NSX Data Center, one of the first things our customers tend to do is write a single rule that disallows any communication between all of the virtual desktops in their environment. And that significantly shrinks the attack surface for an attacker that has gained access to one of those instances. Think back again to that anatomy of an attack scenario. If that desktop didn't have access to any other VDI instances in the entire environment, there were only so many places it could then go, right? Now, that brings us to our next use case: protecting EUC management and protecting desktop pools. Now, if you remember the slide I showed where we had the PCI scope and all of the VMs or servers encapsulated within that scope, this concept is now blown into a full-blown use case here. So with NSX, we have the ability to define policy based on pools of resources, right? So whether they're the management systems for the virtual desktop environment themselves or any systems that are connected to those virtual desktops, we can microsegment and make sure that those systems only have the access that they absolutely need in order to do their jobs. We have a lot of customers that also use different pools of virtual desktops themselves. Forget the management systems and the servers, but the actual desktops themselves are used for different things. So for instance, we might have a developer pool and a contractor pool, right? Where you have desktops that are specifically built and deployed for developers as they come on, and likewise for contractors. And really, there's no reason for those two pools to ever communicate. So not only can we microsegment within the pool, but we can actually microsegment between the two pools. So an attacker has very few places to go and can't just jump around in the environment. Let's look at a few more use cases. So I'm going to, again, start on the left-hand side here with identity firewalling. One of the really cool features about NSX, as I mentioned before, is the ability to define policy based on really any context we want. Could be regulatory compliance scope, could be things like operating system or technical attributes of the environment, but it also could be based on user identity. So you'll see in the top example within this box, we have a user logging into a virtual desktop who is only going to get access to the application if the user credentials, if the identity of that user matches the policy. So basically, we're doing identity-based firewalling. Now we can take this concept a step further and actually go down to 2 users using RDSH sessions or something like that to access an app. And based on the actual RDSH session, we can dictate which user gets access and which user doesn't. So even if they're using the same desktop itself, we can still mitigate their access based on identity. Everything in the NSX world is about giving you fine-grained network security control and giving you the ability to manage it centrally and easily. This just goes to show you just how deep we can take that concept if we really want to. And of course, this gets back to the idea of the value proposition of helping in these persistent or non-persistent desktop environments where you're constantly recycling desktops. In the end of the day, it shouldn't matter what the IP address of that desktop is. We want to be able to firewall based on things that are much more granular and much more specific than that. Now, I'm going to move into a subset of use cases that really help to highlight what we can do from an NSX perspective to increase the your previous security investments. So no doubt you've already made investments in things like antivirus or endpoint endpoint security products. You may have also employed or made investments in big next-gen firewalls, things like that on the network side, IPS systems, things like this. And NSX can actually help you get more value out of those solutions. We'll start with agentless antivirus and anti-malware. So of course, in a normal environment, you would deploy agents to all of your desktops or servers, and those agents would be running. Oftentimes, they lead to performance impacts. But of course, you don't want to sacrifice security, so we kind of put up with the performance headache and the management nightmare of managing all these agents in the name of security. But with NSX, one of the things we can do is actually offload those agents from the desktops or the servers to the hypervisor and allow the hypervisor and a service VM hanging off of this hypervisor to bear the brunt of that performance impact without actually sacrificing any security within each of those desktops. The other beautiful thing about this is if you're using one of the antivirus vendors that we partner with, and I'll get to that in just a second, they can actually use NSX when they detect something to respond. So not only can we increase the performance of all your desktops without sacrificing security, but we can actually increase the power of those AV products by allowing them to do things like quarantine a VM or a desktop or something like that using network security policy in NSX. We can take that even further if we begin talking about service insertion and the ability for NSX to insert third-party security services into microsegments. So for instance, let's say you not only found something on a virtual machine or a server that you wanted to quarantine, but maybe you also wanted to insert some sort of IPS service between that VM and the rest of the network. You could do that using service insertion. And this is a very powerful tool. We partner with some of the biggest next-gen firewall vendors, IPS, IDS, vulnerability management vendors out there. Which brings me, of course, to, if you're using any of these vendors in your environment today, and these use cases are interesting to you, and you're curious how we could potentially help you get more out of these investments, because we know, security is oftentimes not cheap, and it's a tax we all pay because we all want to be secure. But in the security world, it's all about how do we get the most bang for the security bucks we spend. And if you're already using any of these, particularly that networking and security services row there, if you're already using any of these vendors, definitely get in touch with your VMware sales rep and ask how you can help get more out of that. Okay, so that was a lot of information. So I want to sum it up really quickly. But basically what you're getting when you combine NSX with Horizon is not only all of the awesome security enhancements that Horizon brings to the table from an end user device or end user desktop security perspective, but you also get the security that you need to secure that VDI deployment itself. And that's all down to microsegmentation. We give you the ability to consistently define and deploy security policy across your entire infrastructure. Not only that, but we allow you to do it in an automated fashion so that as you're using non-persistent desktops, as things are changing in your environment over time, you don't have this lag between when something becomes available to an end user to use and when security is deployed and provisioned for that resource. I should also mention here that NSX, you may have noticed this when we were talking about the architecture earlier, but NSX does more than just firewalling. It does full-on network, virtualized networking as well. So from an automated deployment perspective, one of the other benefits is you can actually automate the connectivity aspect of bringing that workload online as well. Just another tidbit, not necessarily a focus of today's conversation, but something to keep in mind. Now, finally, we also give you centralized control, the ability to manage all of this network policy, security policy, etc., from one centralized management plane that extends across your entire environment. Now, the other, the one other note I'll add, it's not just across your entire environment, but it's without the need for hardware. And speaking of the need for no hardware, the entire model that we've talked about today, from consuming desktops to securing desktops, is also cloud consumable using two products called Horizon Cloud and NSX Cloud. Very clever names, we know. But basically, the point here is that if you wanted to consume desktop as a service and secure that with the full-blown networking security component that we've been talking about in this webinar, you can do that using these two products in a cloud model. Lots of our customers like this. We've got plenty of customers actually doing this today. I'm not going to talk about one right now. I'm actually going to flip back to the on-premise world for a second to talk about our next use case. But I wanted to highlight this, make sure that it was available, and we do have some case studies online if you're interested in reading more about that. Okay, so let's talk about the reality of the situation in our customer environments. Vallejo Sanitation Flood Control District is responsible for, as the name suggests, making sure that us Californians have safe, drinkable water, and that the control planes here in the flood control planes in California are adequately monitored. And they recently embraced an entire suite of EUC products and user computing products from us. They not only have Horizon to do virtual desktops, but they also deployed AirWatch, which is a mobile device management solution that can be deployed to things like phones, laptops, tablets, etc., to do some mobile device management as well. Now, as we've talked about today, all of these products integrate with NSX in order to secure them from the back end, right? So not only was Vallejo looking to maximize the efficiency and effectiveness of their teams in the field with all of these device management systems that are out there protecting them, but they wanted to make sure that within their data center itself, it was only manned by a couple people, by the way, so that was part of the problem as well, that they were secure within the data center itself. And therefore, they went with NSX because they had a small team and they knew that automation was going to be a really key part of their security posture in order to be effective. Now, they've been using the solution for a little while now. I believe it's a year or two, and it's been working pretty extraordinarily. They've seen not only, of course, the increases in performance that you would expect, or I should say efficiency that you'd expect when you move to a more of a BYOD model within your environment, but they are able to completely control and maintain this security model within their data center with a very small team. And that's all thanks to the power of these solutions working in concert with each other within the VMware ecosystem. So actually, if you'd like to see, there are some great videos of Vallejo on the web that you can check out, and you can hear it from their perspective, not just mine. But there are lots of other places that you can learn more about the products if you are interested in what you've heard about today. First of all, you can test drive these products in our hands-on labs. I highly encourage you to do this. It's a great place to get your hands on the products themselves, use them, play with them, explore different use cases with them, and even see them interact and work together in certain ones. There's a whole library of hands-on labs available for you at the URL listed here. Definitely get in there, play around, and have some fun. Of course, you can also learn lots more about how these products, the products individually or how these products work together. If you check out VMware.com, we have some solution level white papers and resources. We have some product level white papers and resources in case you're interested in learning more, or you have colleagues that you think might benefit from hearing about some of this and getting their hands dirty with it. So with all of that said, I want to thank everybody for joining, extend the thanks as well from Brigitte as well, and the whole VMware community here, and hopefully we'll hear from you soon. Thanks for joining, everybody.